Okay, let's look at the indefinite integral first. And you get this over here. Whoops, let's get back to black ink. By the way, I know there's problems, and right now I'm not too worried about the problem. You know what? I'll write the limits down. And let me put this over here. So I'm going to say u equals ln x. By the way, this integral is improper. And the reason for that, at 1, you're going to get division by 0. All right, let's not worry too much about that, though. So maybe I'm being a little sloppy by saying that. So du would be 1 over x dx. Let's write this down. And that when x is 1, u would be 0. When x is e, u would be 1. Whatever you'd get 1, you definitely get, let's see what you get. We got to figure this out. So you would get u to the p. Right, because ln of x is u, and dx over x is just du. All right. I guess I should write a limit down now. Again, the question is what value of p would make this convergent. So let me get my eraser out. I don't need it. I'll keep that there. I want to keep it there. Actually, I don't need it anymore because I don't need to go back to u's. I'm in x's. I'm in u's now. I'm going to stay in u. So I'm going to write down, I'm actually trying to figure this one out over here. And I'm going to erase this too. I don't need this anymore either. I'm doing this. And I'm going to write down limit now as, let's see, a goes towards 0 from the right side. And then you're going to get, let's see what you get over here. There's going to be some cases to consider. And one case to consider is when p equals 1. So let me put this over, when p equals 1. I'll do this case first. That's going to be the natural log of u, absolute value of u. Limit integration would go from, let's see, a to 1. Let's write this over here. Limit a goes to 0 from the right. This is going to be the natural log. Well, that's just going to be a. I'm sorry, 1. What am I saying? A, 1. I did it again. Minus the natural log. And since a to the right is 0, I'll just put a over here. And natural log of 1 is 1. And this is going to be natural log of a as a goes towards 0 from the right is minus infinity. So it's going to be infinity. So if p equals 1 is not convergent, let's do p greater than 1 now. And let's write it down. It's still going to be this integration 0 to 1. 1 over, I'm going to write a little bit differently. It's going to be u, well, I did it again. I keep doing that. That's going to be u to the minus p du limit as a goes to 0 from the right side. This is going to be u. I'm going to increase the exponent by 1. So 1 minus p over 1 minus p. And I got to be real careful now. This is going to go a to 1. Let's write this over here. Limit a goes to 0 from the right. Let's see, I put a 1 there. I just get 1 over 1 minus p minus, that's going to be a, 1 minus p over 1 minus p. Time to think. Someone says, what are you thinking about? I'm thinking about this thing over here. And when you go there, 1 minus p, if p is greater than 1, that's going to be a negative number. So I'd get 0 to a negative number. So it's going to be, like 1 over 0 to a positive number. Well, that's no good. That's going to blow up to infinity. So this one over here is going to blow up to infinity. All right? Let's do p less than 1 now. Well, I did the groundwork already. I'll do it over here. 0, 1, u minus p du, limit. You know what, I gotta get my eraser out. I'm gonna erase this over here. I'll just jam it in up here. All right? So limit as a goes towards, before I say the infinity, I gotta think about that again. So you get 1 minus p, that goes to 0. 1 minus p is, if p is greater than 1, it's negative infinity, sorry. All right? I got to think about it again. Let me just, before I commit to it. So 1 over 1 minus p, that's fine. And then you get a, which is going to 0 from the right side. 1 minus p is a negative number. So you get, that's going to blow up to infinity. And 1 minus p is negative. Yeah, I'm okay. I hate to do it. I have to think about that again. Let me write it down. Minus, that's going to be 0 from the right side to p minus 1 now. Write that down. And then 1 minus p. So the bottom, is going to be, let's see, negative. Yeah, it's plus infinity. I'm sorry. Let me get my eraser and get rid of this nonsense over here. All right, let's do this one over here. A goes to 0 from the right side. Really doing the same thing. It's going to be u. I'm going to increase the exponent by 1, so 1 minus p over 1 minus p. The integration is going to go from, let's see, a to 1. All right, same thing, limit. A goes 0 from the right. And then you're going to get, let's see, if u was 1, you'd get 1 over 1 minus p. And then, let's see, minus, you would get a to the 1 minus p over 1 minus p. Well, again, it's time to think. This guy over here, it's going to be, 0 from the right. And 1 minus p, if p is less than 1, going to be a positive. So that goes to 0. So that's pretty easy, I think. So what do you have there? You get, I'll write that down for you. You get 1 over 1 minus p. So I'm going to say it converges just for this over here. Let's just look at the key, though, and sort of like, kind of going through it. And, I put down the antiderivative. I did a little differently. For p equals 1, I said infinity. Did I do that? Yep. For p greater than 1, a d and e. That's fine, too. And for p less than 1, I said this over here. We did okay. So it only converges for p less than 1. And that's what we set up here. This only converges for p less than 1. We're done. Next question. Thank you.